Who here is familiar with drug-resistant bacteria? Anyone? A couple of people? Unfortunately, this is a topic we're going to become more and more familiar with in the next decades. The World Health Organization considers drug-resistant bacteria one of the top 10 threats to human health right now. So what are drug-resistant bacteria? For those of you who aren't familiar, let me give you a little bit of an introduction. Normally, if you get a bacterial infection, you go to the doctor, receive antibiotics, and when you take them, you recover. But with drug-resistant bacteria, you might not be so lucky. These bacteria won't respond to the antibiotics, and you could develop complications or even die. One of the main reasons that drug-resistant bacteria are thought to develop is because of the overuse of antibiotics. Did you know that in Canada, annually, 70% of the antibiotics that we use are not used in humans, but rather in livestock, like cows and pigs? Small amounts of antibiotics are incorporated into livestock feed to keep the animals healthy. But because of the low dosage, it's possible that the bacteria will survive and develop resistance. So the question becomes, how do we keep both ourselves and the animals healthy? And that's where my research comes in. I'm developing copper nanoparticles that can be incorporated into animal feed to replace the antibiotics that we use. And because copper nanoparticles use a separate mechanism than antibiotics to kill bacteria, even if bacteria were to develop a resistance to copper nanoparticles, we would still be able to use antibiotics in humans successfully. Now, there are some important design criteria that come into play when you're trying to create nanoparticles that you can feed to animals. There are three major components that go into creating a nanoparticle: the metal salt, which is where the metal itself comes from, and reducing and capping agents, which take the metal ions and build them into the nanoparticles that actually kill bacteria. Unfortunately, most of the reducing and capping agents that are commonly used are also highly toxic. And while technically we don't have to worry about whether or not a dead cow is feeling sick, that's not the ideal outcome. My research circumvents that by using natural plant-derived reducing and capping agents. So I'm using cellulose nanocrystals, which come from trees, wood pulp, or even agricultural waste, as the capping agent, and tannic acid, which can be derived from galls from oak trees, as the reducing agent. When I combine these with my copper sulfate salt, the metal precursor, I'm able to generate cellulose nanocrystals that are covered in these bacteria-killing copper nanoparticles. And because I'm able to control the amount of copper in each dose, I can actually tune the system to optimally kill foodborne pathogens like E. coli without harming the animal host. So, drug resistance is something that we absolutely have to curb now. If we don't address drug resistance, we could be looking at upwards of 40,000 deaths a year in Canada by 2050 just because of drug-resistant bacteria. And my system is one of the first steps towards addressing this problem while keeping both the humans and the animals healthy. Thank you very much.